In this episode, we will be looking at some of the secondary effects that bits of the aircraft can produce. This includes the ailerons, the rudder, and the engine. So, let us depart on this truly fascinating journey of knowledge. First of all, we will look at the secondary effects of the primary flight controls. One thing worth mentioning before this is the fact that when you create lift, you also create induced drag. As you will remember from episode 5, roll is achieved by increasing the lift on one of the wings, and reducing the lift on the other. When rolling to the left, there is less lift on the left wing, which means there is less induced drag on this wing, when compared to the right. Looking at the aircraft from above, and putting in arrows representing the induced drag while the aircraft is turning, should mean that you can see that the aircraft will yaw to the right. You will now have this situation, while the ailerons are in use. The aircraft is rolling to the left, but yawing to the right, and slipping in the turn. This is known as adverse yaw. Once you have your desired bank angle, and you return the ailerons to the neutral position, the drag on both of the wings will equalize again. Airflow, coming from the left due to the turn, then causes a lift force at the tail, yawing the aircraft to the left, and the aircraft will now be facing in the direction of the turn. Left unchecked, the aircraft will go into a spiral descent, which isn't too good for anybody involved. However, the introduction of a little rudder into proceedings sorts all this out. We can minimize the effect of adverse yaw by using freeze ailerons. Since the upgoing aileron creates less lift, and therefore less induced drag than the downgoing aileron, we need to create additional drag here. On freeze ailerons, this is achieved by moving some of the aileron into the airflow when it is deflected upwards. This will then balance the drag on both ailerons. Differential ailerons can also be used. The downgoing aileron creates lift, and therefore induced drag. To even everything out, the upgoing aileron deflects upwards more than the downgoing aileron deflects downwards. Again, this should help keep the two wings generating similar amounts of drag. So, the primary effect of the ailerons are to roll the aircraft, but the secondary effect is also to yaw it. The rudder is also an intrigue, wrapped in mystery, inside an enigma. When yawing the aircraft to the left, airflow over the right wing is faster than that of the left. From the lift formula of episode 3, you will remember that faster air results in more lift. More lift on the right wing compared to the left will then result in a roll. Note that we have not touched the yoke, and the ailerons are still neutral even though there has been a roll to the left. Again, a spiral dive can develop if you don't do anything about this, which is unfortunate. The primary effect of the rudder is to yaw the aircraft, but the secondary effect is also to roll it. As well as the secondary effects of the primary flight controls, your engine can have quite a lot to say about how your airplane flies. The airflow it creates around your aircraft will change the sensitivity of the controls. In this Cherokee, for example, high power settings will result in sensitive elevator and rudder controls, due to lots of air being chucked backwards and over these control surfaces. Low power settings will result in heavier controls. This is important to bear in mind when performing a go-round, and therefore quickly moving from a very low to a very high power setting. Using the same heavy-handed control movements after applying full power may have unfortunate consequences. The propeller also causes the airflow to rotate around the aircraft. Most propellers rotate clockwise, and therefore the airflow strikes the fin on the left, producing a sideways force on the fin from the right. This will result in a left yaw. A clockwise rotating propeller will also want to rotate the aircraft left, due to torque reaction. This is like holding a fast-spinning fan. It is revolving one way, and is wanting you to revolve in the other. This also makes the aircraft want to yaw and roll to the left. If you don't remember this at takeoff, and put on full power without any right rudder, bad things can happen. Ta-ta for now.